Assalamualaikum, a very good day. Today we will discuss about interest and equivalence, part B, based on this module 11. This is the overall context that we will discuss. We start with starting from the verifying and analyze the engineering economics based on interest and equivalence, simple interest, compound, single payment, uniform series, either sinking or compound amount, capital recovery, uniform series or uniform gradients, and after that we will discuss on how we want to use the table guide to calculate the compound interest. Let's see the first single payment that we will conduct the calculation based on the compound interest, not a simple interest, compound interest. Single payment, we only pay one time only, and then after that we want to know what happened to our money in the future value here after a few years, 10 years here. This is the objective of the single payment, and the formula to calculate the future value based on this single payment is equivalent to single payment here multiplied by 1 plus I is the interest rate on the n years here. So for example, by using the single payment, when we want to find the future value f here, let's say if you saving your money 300 ringgit today, what happened to your money after 5 years? So the first thing that we need to do is we calculate, okay, 300 ringgit here, 300 ringgit, your P value, and then after 5 years, starting from year 0 here today, and then we want to know what happened to your money after 5 years. So we call it here as what happened to your money in the future 5 years. So if we calculate those, we'll see that finding f when we knew the p, finding f here when we knew the p, and also your I interest rate here. So your p here is 300 ringgit, and then your interest rate here 10% is equivalent to 0.1 in 5 years. 5 years here. So you'll see that finding your future value when you knew the p here is equivalent to 300 multiplied by 1 plus 0.1 at year of 5 years here. You'll see that your money will become 483 ringgit. 483 ringgit. Okay, yeah. Alright. If we calculate using the simple interest, you only can get your money around 450. Just a calculation without a compound interest. Almost 33 ringgit in 5 years. The difference. Let's see the second example here. Let's say we make a saving in the bank 10,000 today. What happened to our money 4 years from now? We interest rates of 10% here. So this is our money at year 0 here, 10,000. We want to know after 4 years with 10% of interest rate, what happened to our future value. So if we insert all of this value here in our finding f when you knew the p, finding f when we knew the p here at I interest rate of 10% and n is 4 years here, we will see that our money in the future instead of 10,000, now it become 14,641 ringgit, 4,000 more compared to 4 years ago, only 10,000. And if we calculate without a compound, we using the simple interest, we will see that our money, instead of 14,641, our money is only 14,000 ringgit. A clear difference in 4 years here. By using a single payment, we also can find an I value. So let's see this example. Let's say you want to save your money 800 today. 800 today. You want your money to accumulate in 5 years here to become at 12,000. So how much annual interest rates that you need to find out here so that your 800 here will become 12,000 in 5 years. Let's see the solutions here. We know that the formula is finding f future is equivalent to p multiplied by 1 plus I with power n, and then we just calculate according to I here. We see that the I is equivalent to f over p at power 1 over n here minus the 1 here, and then we insert all of these value in this new formula. Okay, 12,000 divided by 800 here, p here, power 1 over 5 here, year 5 years here, minus the 1, and then you will see that our interest rate here is equivalent to 71%. So in 5 years, if you just save 800 here, if you want to have 12,000, you need to find whoever that can give you this amount of interest rate, 71% of interest rate. So which institution should you select, Sharon? Let's see an example here. We save our money 1,000 today, and we want our money to accumulate in 6 years. 6 years here to become 10,000. From 1,000 here to become 10,000 in 6 years. So what is your targeted annual interest rates here? Okay, we use the same solutions here. F equivalent to P multiplied by 1 plus I at n years here, and then we got the I formula equivalent to F over P at 1 over n minus the 1 here, and then we insert our future value, and then after that our present value here 1,000 here at 6 years here. I will see that our I will become 46.8%. Okay, 46.8% interest rate if you want to accumulate your money from 1,000 to 10,000 in 6 years. By using a single payment, we also can find out what is the end value here. Okay, let's say you make a saving of 1,300 ringgit today with 8% of annual interest rate. Okay, you save at any financial institutions there, they give you 8% here. How many years? Okay, how many years you should work so that your money will be exceeding 12,000 so that you can pay your first car installment. Okay, how many years that you need to wait. So the solution is based on F equivalent to P multiplied by 1 plus I at n here, or n, so that we just take the n here to become our equivalence formula to become log of F over P divided by log of 1 plus I here, and then we insert all of this value. F here is 12,000, P here is 1,300 ringgit, and I interest rates of the 8% equivalent to 0.08, and then you will see that our n here log of 9.23 divided by log 1.08 here, we'll see that we need 28.9 years your money to accumulate from 1,300 again to become 12,000. So you need to wait. Okay. In other words, we need to wait for 28 years. So then you can buy your first car. Okay. Just an example for our thoughts here. Let's see that we save our money 2,000 today. Okay. At any financial institution that give you 7% of interest rates here. The question is how many years? Okay, how many years we should wait so that our money will be exceeding 15,000 there, so that we can use those money here to get married. Okay, for the commitments of our wedding ceremony and so on. That we want to know how many years that we need to wait, starting from our 2,000 saving here. So if we calculate equivalent to n log f over p divided by log 1 plus I here, 15,000 divided by 2,000 of log 1 plus 7% here, we will see that we need to wait 29 years. Okay, 29 years based of our single payment here, 2,000, to accumulate to become 15,000. Do you have that time to wait?